This is lesson 2. It's finding solutions to absolute value equations as well as linear functions. Then it kind of covers finding the solutions to equations in general. So basically, what we're doing is it's kind of a recap. The connection here in Algebra 1, you factored equations, you graphed equations, and let's say you were given a graph, you were given some curve, you're expected to find these x-intercepts. And what it enables you to do, it enables you to basically find critical points on an equation. Critical points being those where a function is typically considered at rest. Yes, it still goes past it. Yes, it still goes above it. But typically, a function is considered at rest when it crosses the x-axis. You can identify those points. You can see those points. What you can do with these critical points, let's say this is -4, this is 0, this is the x value of 3. What you're able to do is then craft an equation. And let's say my equation here, it could be x, the opposites, x plus 4, times x plus 0, or just x, times x plus, we'll say, -3. So if you notice, these numbers, these factors are opposites, with the exception of 0, because 0 is just 0. So we're just going to get started here, okay? So, so the solutions of functions have a couple of different names. We refer to them as the solutions. We also refer to them as x-intercepts, which you're used to seeing by now, x-intercepts. And then we also kind of recapped on the phrase zeros. So I'm going to go ahead and get started. So the solution of functions, questions that ask for solutions of functions are generally referring to the x-intercepts. And this is where the object crosses the x-axis. Like I said, they are also referred to as zeros. And a good way to identify these solutions is to circle where the object crosses the x-axis and write the ordered pairs of the points. So here, this linear equation crosses the x-axis at 2. So my solution would be 2, 0. If I was going to write it in 0 form, I would just write the x value. For the next one, I have -5 and 3. So my solutions are -5, 0, and 3, 0. Following that, this vertical line has a solution at -4, 0. In 0 form, it's just x equals -4. Over here, x equals -5 and 3. Okay? So this kind of covers, this particular lesson covers finding solutions graphically, which we're doing right now. And then we're going to find solutions algebraically for not only absolute value equations, but also linear equations. So without a graph, you use the TI-84. So we're going to follow the directions here. So first, we're going to make sure that we rewrite the equation in slope-intercept form. Make sure you have your TI-84. You type the equation into the y equals screen. So I'm going to rewrite this as y equals 2x plus 7. Go to my graphing calculator, go to y equals, and clear out anything there. And I'm going to put my equation in. It's 2x plus 7. And we're going to pause for a moment and not really go follow the directions. We're just going to press trace so we can look at the function. And if I look, my 0 is right about here. I really can't tell what this number is. So what you can do, we're going to follow directions starting with step 2. We're going to press zoom, then we're going to press number 2, and that didn't work. Press zoom 6, and it zooms in. If you press enter, we're zooming in. And it's not zooming in the way I need it to. So we're going to press second calc, and we're going to go down to number 2 for 0. And then we're going to go to the left of that 0 and then to the right. So my graph kind of looks something like this. So the left side of that 0, I'm going to press the left hand button, the cursor button. And for the left bound, I'm just going to go a little bit past, press enter. Then I'm going to go to the right of that 0 and press enter. And it's going to tell me exactly what it is. And this 0 is at negative 3.5, comma 0. So negative 3.5, comma 0 is my x-intercept. For the next one, we're going to be doing an absolute value equation. And you should have 2 solutions always with absolute values. Or in 0. You either have 2 or you have 0. So we're going to do the y, clear everything out. And this is the absolute value. So we press alpha window number 1. And we're going to put this, insert this function, 3x minus 1 minus 8. Okay. And I'm going to go to second. I'm going to press trace first. Press trace. And if I look, I have 2 zeros. One of them I can kind of tell that it's at 3. The other one I cannot. So we have multiple things to do here. So we're going to press second calc, and we're going to find the first 0. Go to 2, press enter. We're going to go to the left of that first 0, enter. And then we're going to go to the right of that first 0, enter, enter. And the first one is negative 2.33, negative 2.33, comma 0. The second one I'm pretty sure is at 3. So I'm going to go back to second calc and press 2. I'm going to go to the left of that 0, press enter, go to the right, enter, enter. And I have a 0 at 3, comma 0. So I have 2 zeros there. That's how you do that graphically. That's how you do it graphically with your graphing calculator. Just follow the steps. Now, when you're looking for linear solutions, first thing you need to check, don't read the steps yet. Am I given, if given, if you're given, if given, f of x equals, or y equals, you're going to change f of x to equal 0 or y to equal 0. If you're given an equation, you might be given an equality in the form of the first problem. Then you have to follow the steps. So first, look at both sides of the equations. And you're going to distribute if necessary. If you look at it, you do need to distribute this negative 4. So 10x just comes down. Minus 4x plus 8 equals 12x. Distributing the 7. 7 times x is 7x. And then 7 times 3 is positive 21. Now we're going to see if we have to combine like terms on either side of that equal sign. And we do. If you can't see the like terms, I'm highlighting them. I have to combine these like terms and these like terms before I do anything else. Okay? And this becomes 6x plus 8 equals 19x plus 21. And then we're just putting our x terms on one side and number terms on the other. So 6x minus 6x on both sides of this equation. I get 8 equals 13x plus 21. Subtract 21 on both sides of this equation. I get negative 13 equals 13x. This goes away. And my x, I divide by 13 on both sides. And I get that my solution is x equals negative 1. You could, of course, put it in x-intercept form, but they're not really asking for that in this case. On the other hand, my second equation, it says f of x equals 5x minus 8 times the quantity of 2 minus 4x. Now remember what I said, if you're given f of x or y equals, you're going to change those to 0. So this becomes 0 equals 5x minus 8 times the quantity of 2 minus 4x, and then you're going to solve for x. Now, going through the rules, distribute if necessary. I do need to distribute negative 8 to the positive 2 and negative 8 to negative 4x. So 5x just comes down. I get negative 8 times 2 is negative 16. Negative 8 times negative 4x is positive 32x. Now I can combine like terms. If you're having trouble seeing the like terms, then my like terms are 5x and 32x. Make sure you drop down to 0, guys. Equals 5x plus 32x, and we get 37x. All right. Now, I need to get the x term by itself, so I'm going to add 16 to both sides. And I get that 37x's equals 16. Divide 16 on both sides, and x equals 37. I'm sorry. My bad. Forgive me for going way too fast. So lesson learned. Please slow down when you're working, guys. All right. So I'm not adding 16 to both sides. Well, actually, I am adding 16 to both sides. 16 equals 37x. Okay. 37 divided by both sides. And I get x equals 16 over 37 for this particular answer. Okay? Now, going to the next page, equivalent equations. So the way equivalent equations work is that you're only thinking about this for only for linear equations. Only for linear equations, because we're talking about equivalent. So we're not talking about linear inequalities. So first of all, in order to find out if two equations are equal to each other, that's the goal. Put the equations in slope-intercept form. And we're going to identify the slope and the y and the y-intercept. So it should be like this: y equals m times x plus b. Here's the slope. Here's the y-intercept. Okay. Now, finding equivalent equations, you do it by putting the equations in slope-intercept form. If the equations have the same slope, m, and the same y-intercept, b, then they are equivalent. Okay? They are equivalent. So far, so good, guys. Now, looking at the first equation, this is, well, directions actually. 3 of the 4 equations are equivalent to each other. Which equation is not equivalent to the others? So I need m and I need b in order to get that. So first, I'm going to solve for y. So I'm going to rewrite. Okay. Now, solving for y, that means I'm moving the x term. This goes away. Negative 4y comes down, equals 5 minus 3x. Divide by negative 4 all the way across. 4's cancels. Y equals 5, negative 5 over 4, plus 3 over 4 times x. Now, your slope for this first one is 3 over 4. Y-intercept is negative 5 over 4. Okay? So far, we're looking for equations with the slope of 3 over 4 and a y-intercept of negative 5 over 4. So I'm going to erase what I've written so far. And we're going to do the next one. The next one, I'm just going to write that in here. M equals 3 over 4. B equals negative 5 over 4. The next one's already in slope-intercept form. Here's my slope. Here's my y-intercept. So M equals 3 over 4. B equals negative 5 over 4. So these are equivalent. So I'm just going to write yes. Yes, equivalent. Now the next one, I want to solve for y by dividing by 4 all the way across. My x term is on the same side as that number term. So y equals 3 over 4, x plus 5 over 4. So m equals 3 over 4. B equals 5 over 4. This is a no. So I'm going to assume, so in the directions, it says 3 of those 4 equations are equivalent. So that I'm going to assume the last one is as well. But I'm going to solve for it. So first, I'm going to switch some things around here so I can see a little bit better. I'm going to say 12y plus 15 equals 9x. I want to get the y term by itself, so I'm going to subtract 15 on both sides. And I get 12y equals 9x minus 15. Divide both sides by the coefficient of y. Y equals 3 over 4x minus 5 over 4. Given this information, my slope is 3 over 4. My y-intercept is negative 5 over 4. So yes, this equation is equivalent to equation number 1, number 2, and number 4 are equivalent. All of those are equivalent. Okay? Now, the next part, we're going to be solving absolute value equations. So this is what I'm going to need you to do. I'm going to need you to highlight what's inside of the absolute value. I'm going to highlight this because something special happens to what's inside. We don't touch it. We look at what's outside. Now look at what's outside of this equation. Don't look to the left of the equal sign, the right of the equal sign, but look what's outside of the bars. Now, things that are important here. If you are adding or subtracting a number to what's inside the bars, this inside, you do the opposite first. Okay? Now, if you are multiplying or dividing a number in front or below, you do the opposite first. You do the opposite. Adding or subtracting always comes first. It's like a backwards way of solving for y, or solving for a variable. So if you look at the first one, there is a coefficient outside. It's 2. That means I need to do the opposite. It's multiplied there. It's like saying 2 times k minus 2 equals 8. You are going to have to divide this 2 away. Okay? That's going to leave me with k minus 2 equals 4. Now, where are we at in the directions? We did not create a table, so we're going to do that. Here's my table. Okay? Do we add or subtract any numbers except coefficients outside of the bracket? We didn't have to do that. I want you to put a little arrow here. We got to insert multiply or divide any coefficients as necessary. That's done. We divided out the 2, the coefficient that was in front. Number 3, rewrite the equation on one side. Replace the brackets with parentheses. So I literally have k minus 2 equals 4. Okay? I don't really need those parentheses, so I'm just going to erase them. K minus 2 equals 4. Okay? On the right, rewrite the side with brackets and replace them. K minus 2. Number 5, write the equal sign, change the sign of the expression. It equals. So do the opposite. So what I'm referring to, if you're confused, what I'm referring to, So this number here is going to be the opposite of what's there. So this is going to become equals -4. And all you do after that is solve for the variable. So here on the left hand side, I'm going to add 2 to both sides. I get k equals 6. On this side, I'm going to add 2. K equals -2. Those are my two solutions, and you would write them k equals 6, -2. Okay? If it was set notation, it would be curly bracket, k bar, close curly bracket. Okay? Next one, going back through, I'm going to create that table. All right. Now it says add or subtract any numbers outside of the brackets. My number outside of the brackets is -8. So I'm going to add 8 to both sides. And I get 3x plus 7. The absolute value of 3x plus 7 equals 15. All right. So now I'm going to follow the directions. I can skip multiplying and dividing any coefficients. And I'm going to have 3x plus 7 equals 15 on one side. 3x plus 7 equals -15 on the other. Now, solving for x on the left, I'm going to subtract 7 from both sides. And 3x, this goes away, comes down, equals 8. Divide both sides by 3. And I get x equals 8 over 3. So I'm going to write these in set notation. Waiting for my second solution here. -7 on both sides. 3x comes down. Equals 8. I'm sorry. -22. Divide by 3 on both sides. And I get x equals -22 over 3. And I said I wanted to write that in set notation. So curly bar, curly bracket, x bar, x equals 8 over 3, comma, -22, 22 over 3, curly bracket closed. Now, next, we have absolute value inequalities. So, flip the page so you can see both pages. You won't be able to see it on here, but I'll be reading through those. So when you're solving absolute value inequalities, you'll be doing something similar. Be mindful of, if you're adding or subtracting, nothing happens, that you will be doing the same things. If you're adding or subtracting a number outside, you always do that first. If there's a number outside of the absolute value brackets, you're going to multiply or divide that number. Now, if you multiply or divide a negative number, please flip the symbol. Now we're going to be doing a couple flips here already, just as a matter of course, for which are the characteristics of solving for these kinds of equations. Okay? Now, so you should have the directions. I like to rewrite things just to make sure I am not missing anything. So I'm going to rewrite, and I'm going to use the space above. And I'll tell you what, I'll make this bigger so that it's easier for you and I both to work more effectively. So I'm going to move this over, make it bigger, bring it back, and then we're going to go up so we can see what we're doing here. Okay? Now, rewriting, I have the absolute value of 2m's plus 16 is greater than 6. What I like to do also is just highlight what's in there, right? This part is going to come out twice, all right? And it's going to look like this. Creating my table, I have 2m's plus 16 is greater than 6. And I know I'm going to solve for the variable there. I want to get out my other part, the other half of solving linear inequalities. The distinction between linear inequalities, solving for them with absolute values, and linear equalities is that you're going to not only change the sign of this number here, you're also going to flip the symbol. So you be very cautious and very careful. All right? So far so good. Now let's take our time with this. So if I'm solving for 2m's on the blue side, I'm going to subtract 16. So that m term is going to come down. I have 2m's. This goes away. My symbol comes down. 6 minus 16 is -10. I divide by 2 across each term, and m comes down. I'm not dividing by a negative number, so my symbol just comes down, and I get -5. So I have m is greater than -5. Graphically, they look something like this. A little arrow going to the right. Here's -5. That's what it looks like graphically. So all of those are solutions. All these little m's going towards infinity are solutions. Now, on the other side, I'm still going to take this same first step. I'm going to subtract 16 on both sides, solving for that m term. I get 2m's, goes away, symbol comes down, -22, divide by 2 across each term, and m is less than a -11. So here, I'm at -11, everything's going to the left, all these little m's are my solutions, all right? If I were going to write that appropriately, the best thing to do would be to write what comes first. So if I put these together, if I put these two solutions together, looks something like this. There's a space in between, and now I got some intervals going on. Let's say I wanted to do interval notation, or whether I wanted to do set notation. My solution is going to look something like this in interval notation. It's going to be -infinity. Let me do that in red. So -infinity to 11, -11, and then there's a union, and I have starts back up at -5 and goes on to infinity. That's what my solution looks like with interval notation. Set notation, on the other hand, we have all of our little m's in between. We have set notation is going to be curly bracket, m bar. Speaking of the first solution set, we have m is less than -11. Or m is greater than -5. Close curly bracket. Okay? For the next one, moving on, I'm going to erase all of this, okay? You can replay it and get the information that you need. All right, now, first things first. We need to take care of this number first, and then we're going to take care of that coefficient outside second. So anything outside we take care of first, leave everything else on the side of the absolute value brackets alone. So that means I'm going to subtract 8 on both sides. I'm going to get -3 coming down, absolute values of 5 minus 4x, less than -6. Now, I'm going to divide -3 all the way across because that coefficient is multiplied. And I get 5 minus 4x is less than +2. Okay? So there's my new equation. There's the equation I really want to be working with. So I'm going to erase all of that, rewrite this up top. So not this. I want to work with 5 minus 4x less than 2. And what I find, I'm going to create my table. 5 minus 4x less than 2. 5 minus 4x. And don't forget, flip the symbol, make it negative. Now, one of the things I did wrong was I retained my absolute value bars. So I have 5 minus 4x, and then over here, and then 5 minus 4x on the right. Now, solving for the x term, I'm going to subtract 5 on both sides. Negative 4x comes down, less than comes down, negative 3 comes down. Divide by negative 4 on both sides. X is, oh, it's negative. Flip the symbol. X is 3 over 4. On the right hand side, subtract 5 on both sides. I get negative 4x is greater than negative 7. Divide by negative 4 on both sides. Flip the symbol. So what does this say to me? It's saying that x is less than 3 over 4. It's also saying that x is less than 7 over 4. So what does that look like? Sorry, x is greater than 3 over 4. You could actually put these together. What you're going to find is typically, if you look at your beginning symbol here, if it's greater than, you will create an or statement. If it's less than, you will create an and statement. Okay? So this and statement looks like this. 3 over 4, the smaller number comes first, is less than x, is less than 7 over 4. Okay? And that's my solution. We're going to explore this a little bit more. I'm going to leave it there for you for this part. And I'm going to create a second video for graphing absolute value inequalities. And we're gonna spread this lesson out over 2 days. Thank you guys for sticking it in for me, getting it in with me, and finishing this up. I would like to leave it there. Have a good day.